course. Okay, so step 2 is where we find our critical values. Okay. Sorry, guys. My allergies are in full swing because of all these lovely plants that are blooming all over El Paso. So our critical values, okay, how we do this now, right? We do this by looking in our table, our T table, okay? So this one is just a little snapshot right here of, it only goes to 10, right? Find mine. I like to have my camera up. Mine is right here, all right? And it's page 388. See that? 388. Okay. And it's complete, right? And you can even see on there, I draw the big yellow and line and then the red arrows to show everybody that that's where we are supposed to be looking, right? This is the two-tailed 0.05, okay? So remember, off to the side here, we have degrees of freedom, okay? So we have degrees of freedom on the side, and we'll look in this one column, okay? So if degrees of freedom is n minus 1, what degrees of freedom will we be looking at for this example? Right, if degrees of freedom is equal to n minus 1, it would be 8 minus 1. So we're looking at a degrees of freedom equal to 7, okay? I'll use this one because it's included here. And let's see, I'll get my red back up. All right, so degrees of freedom of 7 right here, right? And we're gonna slide our finger over to this column. And so that is going to be our critical value there, okay? 2.365. 2.365. And so you can write it like this. Oops. So plus or minus 2.365, okay, are our critical values. And so if you remember on our discussion last week, we use our critical values to determine our rejection region. Remember, any t-value that we calculate, if it exceeds the critical value, either this way or that way, then you reject the null hypothesis. Remember, in the tails beyond our critical values is the rejection region, okay? So when we calculate our t-score, we're gonna take that value and move it along this little distribution that we just drew here and see if that value exceeds 2.365 on the positive end, or if it exceeds negative 2.365 on the negative end. If it finds its way in the tail somewhere, then we are going to reject the null hypothesis, okay? All right, now, are we ready for our calculations? Don't say no, because we're gonna do it anyways. All right, okay, so let's look back at our formulas, okay? Now, I like to look at our formulas and think of them like puzzle pieces and see which pieces we have, which numbers or values we already have, and which ones we don't have, okay? We already have n, so we're doing good there, right? We have n, our n is 8, so we have that. And we were also given our population mean. Okay, remember that was the recommended 8 hours of sleep. Okay, so we have that also. All right, so we need to find our sum of x's squared, and we need to find our sum of x, okay, so that we can calculate our estimated standard deviation, and then we can use that to calculate our standard error, and then we can use that to calculate our t. Okay, so we've got to kind of work backwards here just a little bit, but that's okay. We can do it. Okay, so let's see, I'm going to try and move this just a little bit. Okay, so estimated standard deviation. Okay, we've got to find, I don't want to write it double time or else I'm going to run out of room. So we have to find our sum of our x's squared and our sum of x. All right, so let's look back at our data right here, and we will be able to do that. Okay, if you remember, we could do a little chart here and get our sum of x. If we add up this column, we're going to get our sum of x there. And if we add up this column, we're going to get our sum of our x's squared. Okay. Pull up my calculator here so you guys can see it. Let's see. What am I trying to do? Oops. I did not mean to do that. Where are you? That's what I wanted to do. I just noticed yesterday whenever I would start writing, my calculator would disappear, and that was very annoying. Okay, so there we go. Now it looks like we have both up. Okay, so now you can watch my calculator and me write at the same time. Okay, all right, so what we need to do is get the sum of the x's, right? We need to add up all of our x's. Okay, so we get 9 plus 6 plus 10 plus 9 plus 10 plus 12 plus 9 plus 11. Okay, so our sum of x is 76. Okay, hopefully you guys got the same thing. If you didn't, please correct me because I hate going with a wrong number. Okay. All right, now we need to square them. Okay, we need to square them. I can just show you here, right? You could do that and get your squares. If you're like me, oh, you know what? I'm not going to do that because I can't write that small, that nice. So let's just do this, right? If you're like me and you like to practice your squares, you can kind of challenge yourself. All right. Kids call them their doubles, right? 123.
121.
121. Thank you. I'm like, wait, I don't remember that one. Thank you. 121. All right. So there are all of our squares. And so in order to get our sum of our x's squared, we need to add up this column now. Okay, so 81 plus 36 plus 100 plus 81 and another 100 and 144 and 81 and 121, and I get 744, hopefully. Oops. 744. Yesterday's numbers were really big. We were in the 10,000s and stuff, so those were big numbers. These are a little bit smaller and more manageable. All right, so we got those. We know our n is 8, and so we are ready to complete, if you want to look back, we are ready to complete this formula. Okay, the sum of our x's squared, our sum of x squared divided by n, and then everything over n minus 1. Okay, so if you remember, oops, the big number goes here. So 744 is going to go right here, okay, minus then our sum of x here, which I think was 76. Now I can't see it. Was it 76? Hopefully. Yes, 76. And that is going to be squared and then ultimately divided by 8. And then everything is going to be 8 minus 1. Ugh, that does not look good, guys. I did not write that very well. Okay, let's see, I'll do this one better. So now, remember, you just leave the 744 for a little bit, okay? We're going to satisfy all of this stuff over here first, okay? So 744 minus, we need to do our 76 squared, okay? It's going to be a big number, right? 5,776. You could write all that down right now if you wanted, or you could just hold it, oops, hold it in your calculator and just go ahead, oops, why is it doing that? Divide it all by 8, and it just saves yourself a little bit of space and time, okay? I'm writing it out just because I don't want people to get confused on what I was doing, all right? So we went to 5776, and now we need to divide by 8 over here. Okay, so 5776 divided by 8 gives us 722. And that number fits a lot better with that 744, right? I'm going to go ahead and do the 8 minus 1 and go ahead and put 7 right there. So then we have 744 minus 722, which should be 22, but let's just make sure. Okay, I always doubt myself. 22 divided by 7. I don't know where you guys want me to write it. I guess I could continue up here. Okay, so 22 divided by 7. Is this going to work? No. 22 divided by 7 equals 3.14. Oh, that looks like pi, right? Huh. 3.14. Now we need to do the square root of 3.14, okay? This number right here on this calculator, let's see if this is gonna work. Or does it want me to type the number first? Yes. Let's see. 1.77. Ah, that didn't work. How does that look for you guys over there? Okay, yeah? Did you get the same numbers, Cassandra? Yeah? Okay, all right, good. Yay, we kind of remember that, even though it was like long time ago. Okay, good. All right, so yay, one formula down. Now we need to do the other one. This all goes really easy. That's really just the hardest part right there, our standard deviation or our estimated standard deviation. So now we're going to take that value, 1.77, sorry, and we're going to divide it by the square root of our n so that we can get standard error. Okay, so so standard error will be equal to 1.77 divided by the square root of our n. Okay. So the square root of 8 is equal to that 2.8, we'll round it up to 2.83. So 177, or sorry, 1.77 divided by 2.83, we get 0.63. I'm going to round it up to that 3, okay? So our standard error is 0.63. See, I told you that one would go fast, right? And now we get to do our t-test. However, we're missing a number. We're missing a number, right? If we look back at our t right here, we have our standard error now. We have the population mean, or the population, recommendation or average sleep is 8, but we don't know what our sample mean is, okay? But that's okay. We can do that real easy because we already calculated sum of x, all right? And remember, sample mean is equal to the sum of x divided by n. So we have 76 divided by n. 76 divided by 8 is 9.5. So our sample was averaging 9.5 hours of sleep. So we do 9.5 right here minus the population mean divided by the standard error. If you want to look back at it, sample mean minus the population mean divided by standard error. Our standard error we found was 0.63. So we have our sample mean of 9.5 minus 8 divided by 0.63. So 1.5 divided by 0.63, and we get a t equal to 2.38. Okay, so now what? What does that mean, right? What does that mean? Well, we can look back. Hold on, I'm going to put this outline on there. Okay, just so I can find it again. If we look back at our steps, we did step 1, we stated our hypotheses. We did step 2, we identified our critical values. And we did step 3, all of our calculations. Now we need to make a decision, step 4. Okay, so step 4. Oops, step 4, decision time, right? And what we do here is, remember, we make a decision between fail to reject or reject, right? Whether we reject or we fail to reject. So I'm just going to draw this again. We don't just make this up and we don't just say what we think it's going to be. We need to look back at our critical values, right? We had those right there in our step 2, okay? 2.365. All right, so what we do is we take our t value of 2.38 and we compare it to our critical value, and what we see, even though it's very, very close, and this makes me think of a question that we had yesterday, I want to say from Susanna, that what do we do if it's super close or if it's right on top of it? Well, this one makes it, it's close, but it makes it, because 2.38 is bigger, or it exceeds 2.365, okay? So our t-value has found its way into the rejection region, okay? And so what that means, oops, what that means is we get to reject the null hypothesis. All right, you could just put HO, but we'll reject the null hypothesis. Okay. Oops. What in the world? Oh, I don't know. All right, reject the null hypothesis. Okay. And then here, I want you to practice saying what that means, okay? Practice putting that into a conclusion, okay? A conclusion is like for the average person, it's for the lay person, okay? You just put it into words. I always say, if you were telling your mom or your grandma, what did you just find, okay? Word it so that they would understand, okay? So what we found, or does anyone want to take a stab at it? Cassandra, do you want to take a stab at it? Not to put you on the spot or anything.
I'm all trying to figure it out. Could you go back to what they were trying to, or what they were interested in, so you can say
yes
that there's no, or wait, yeah, that the,
you could go ahead and go, because remember, we're rejecting the null. I'm sorry, I didn't want to cut you off, but yeah, you can, since we're rejecting the null hypothesis, we get to say we're right? So then that means we can look at the alternative hypothesis, right? So what we found is there is a difference, right?
Maybe like the amount of hours of sleep, or wait.
Yeah, no, you're doing good. You're doing good.
That, or maybe that, or is it that the regular daily exercise, or that the sleep affects it, or?
Yeah, see, it's kind of hard to word it, right? Because, well, first of all, our brain just doesn't work like this, right? We don't just naturally state things like this. And when researchers and statisticians are doing this, you know, they're writing their papers and they have tons of time to go back and edit and reword what they say. So it is hard to on the spot just come up with that. But I like how you were working through it. So that's exactly right. You know, that sleep, or sorry, regular exercise, does it increase it or did it decrease it? How would you find that out? Do you know? We would look at the sample means, okay? And Cassandra, I'm just talking to you because you're the one that's there, okay? So we would look back at our sample means and we would see, right, in this example, the sample mean of 9.5 was greater than the population mean. And since we rejected the null hypothesis, we can say that this 9.5 is statistically higher than the average of 8 hours. So we can say that the regular exercise significantly increased the number of hours that these participants slept, okay? And so once you're done with your research, and you are able to reject the null hypothesis, then at that point you can go back in your conclusion, and that's where you can say whether it increased it or it decreased it. Okay, you are allowed to go back and do that and say that. And how we would do that, how we would know, is we can look at our sample means and we can see that 9.5 is bigger than the mean. Okay, we can also, this is like a little cheat way. Oops, we had a positive z-score. Okay, or sorry, we had a positive t-value. So since we were on this end, we know our sample was bigger than the population. If we had a negative t-score, then we would know our sample was less than the population. But that's just another way to do it. Okay, so up here, let's see, I'm just going to write it. There is a significant increase. Oops, oh yeah. In sleep for the, I'm not even going to do the, for I don't know, something like that, compared to the average, I guess. I don't know if that even makes sense. I probably didn't even need to put that. So I'll just put for people who exercise daily, right? Just a very simple conclusion. And again, you know, writing this right off the bat does not have to be some amazing literary, you know, work of art, because people who do this on the daily, you know, they are revising, they're editing, they're looking back at things and saying, wait, how can I word that a little bit better? So just kind of put down, you know, something that pops in your head. You know, it increases sleep. It had a significant effect on their sleep. You know, people in the sample slept more than the recommended 8 hours. However you want to word that, okay? It does not have to be perfect, and there's no judgment on my end when I'm reading through that, okay? I'm not going to go over the rest of these slides right here. One, because we're already over our hour, and two, because these are it's effect size, and then it's 2 samples, and we're not going to do that yet. Okay, so this was a single sample t-test. I know it's a lot. I know it's taking in, this is new information. Look over these videos, look over the video from yesterday, look over how we were calculating these problems and these different steps, okay, and how we figure those out. I put up the assignment where you're going to do one of these on your own, and email me, message me, do it in the chat on our discussion board so that other people can see your question also, and maybe you all can answer each other's questions. I'll hop in there if anything, if you're asking me or if anything is going in the wrong direction, of course. So you guys can work together in that sense and help each other out, okay? Do we have any questions right now?
Is the class from yesterday, it's the same slides except it's a different example?
That's exactly right. Yeah, so you could even like fast forward through all my nonsense talking until we get to something like this where we're doing a problem, okay? And that problem is in the book. It was like 9.27 if I remember correctly. And so yeah, it's just different numbers and just another example, okay? Yeah, all right. Oh, we have, let's see, we have a chat. Oh, when is the assignment due? Always a good question. Right now, you know, we'll say like a week or two, but I would really just like you to try and do it before the next exam, so that you have a chance of practicing it, okay? And so that we'll know, where you might get stuck before the test, okay? So let's say, through next week, okay? I believe our exam is supposed to be next week, okay? So that's scary, but I think I'll just have this one on here, not the two
Sorry.
samples.
Are we gonna email it to you or how?
Yeah, you want to just take a picture of it again and email it to me. I think that works the best, and then it allows me, especially with all these calculations, it allows me to see what is happening and where you might be putting numbers incorrectly or something like that. So I would really like to see a snapshot of your work, just so I can help you if you're getting stuck somewhere. Okay, if you've got it down and you put all the answers and it's that way, I'm not going to mark it wrong if I don't see your work. That's fine with me too. It's not like elementary math. I don't have to see your work, but if I can see it, then that's obviously where I can help you if it's incorrect. Okay. So yeah, take a picture and email it to me or something like that. Okay. All right. Any other questions? No? Okay. All right. Well, you guys have a great weekend, and I'll see you next week.